Hello everyone, you're welcome to solve this nice algebra problem, which is 3 to the power of a minus 3 to the power of b. This is equal to that 4. So what is the value of a and what is the value of b from here? Given that a and b, these are members of positive integers, and that a is greater than 0, and that b is greater than 0, and that a is greater than b. So let's prevent the solution from here. So we have 3 to the power of a minus 3 to the power of b. This is equal to 34. We have that a is greater than b from here. So we let a be equal to k plus b. So let's substitute this into the equation so that we have 3 to the power of k plus b minus 3 to the power of b. This is equal to 34. So we have that 3 to the power of k plus b. This is in the form of a to the power of n plus m, which can be expressed as a to the power of n times a to the power of m. Applying this exponent property from here, so we have 3 to the power of k times 3 to the power of b minus 3 to the power of b. This is equal to 34. So we have that 3 to the power of b is common here, so we can factor out 3 to the power of b, so that into the parentheses, we have 3 to the power of k minus 1. This is equal to 34. The next step from here, we can express 234 as 3 multiplied by 78, which is the same thing as 3 times 3 times 26. So here we have 3 times 3, this is 3 squared times 26. So therefore, from here we have 3 to the power of b into the parentheses. This is 3 to the power of k minus 1. This is equal to 3 to the power of 2 times 26. So let's make some comparison here. Let's compare 3 to the power of b and 3 to the power of 2, so that we have 3 to the power of b. This is equal to 3 to the power of 2. And here we have 3 to the power of k minus 1. This is equal to 26. So therefore from here, since the bases are common here, that is a to the power of n, this is equal to a to the power of m. Since the bases are common, exponent n is equal to m. So this implies that from here, that b is equal to 2. Now, we can solve for k from here. Let's take minus 1 on the right hand side, so that we have 3 to the power of k. This is equal to 26 plus 1. So that now 3 to the power of k, this is equal to 27. So we have b is equal to 2, and we have that 3 to the power of k, this is equal to 27. We can express 27 as 3 to the power of 3, so that now 3 to the power of k, this is equal to 3 to the power of 3. Since the bases are common here, that is a to the power of n, this is equal to a to the power of m. Therefore, n is equal to m. This implies that k is equal to 3. The next step is that, if you recall, we insist that let a be equal to k plus b. Let's substitute the value of k and b from here, so that a is equal to 3 plus 2. So that now a is equal to 5. So if you recall from here, we end at 3 to the power of a minus 3 to the power of b. This is supposed to give us a value of 2 234. So substituting the value of a here and b, so we have 3 to the power of 5 minus 3 to the power of b, which is b is equal to 2. So 3 to the power of 2, this is supposed to give us a value of 234. So 3 to the power of 5, in this case, this is equal to 3 times 3 times 3 times 3 times 3. 3 times 3 times 3, this is equal to 27 times 3 times 3, which is equal to 9. So we have 27 times 9. 9 times 7, this is 63. 3 carries 6 from here. 9 times 2, this is 18 plus 6. This is 243. Then from 243 here, we have 243 subtract 3 squared, which is equal to 9. This is supposed to give us a value of 234. 243 minus 9, this is equal to 234. And this is equal to 234. So this implies that the left hand side is equal to the right hand side. And this implies that the value of a, which is equal to 5, and the value of b, which is equal to 2, satisfies the equation. So kindly follow the steps, like this video and subscribe. Like this video and subscribe.